there are unmoved points in polar directions. Unmoved points will constitute a line, a plane, or all of space. So to describe the points which are unmoved by the symmetry, keep symmetry in mind, operations of the point group. You can draw a straight line joining two unmoved points. And this line is called a polar direction. And of course, we're going to use the North Pole and the South Pole as references. And the electric polarization must be parallel to a polar direction. So in polar point groups of high symmetry, the polar direction can be a unique alleged axis of rotation, but if the symmetry operations do not allow any rotation at all, and that would be our horizontal plane, such as mirror symmetry, there can be an infinite number of such axes. In that case, the only restriction on the polar direction is that it must be parallel to any mirror planes. So basically, our horizontal plane does not allow any rotation at all. So therefore, it will operate in mirror symmetry. And there can be an infinite number of such axes. In that case, the only restriction on the polar direction is that it must be parallel to any mirror planes. And of course, I guess you can say based on that information that the North Pole will be a mirror plane and the South Pole will be a mirror plane. Because a point group with more than one axis of rotation or with a mirrored plane perpendicular to the axis of rotation cannot be polar. So you have what you can call polar crystallographic point groups. Of the 32 crystallographic point groups, 10 are polar. The space groups associated with the polar point group do not have a discrete set of possible origin points. Now, in crystallography, space groups are also called the crystallographic or Fedorov groups and represent a description of the symmetry of the crystal. And there's a reason why I am mentioning crystal in relation to our Earth, because its properties act as such, I believe, when viewed from a celestial point. So when you see them post all of these pictures and animation CGI of the globe Earth, of course, you have all of the continents painted outside of it. You have the waters painted outside of it. And that is basically nothing but, I would say, a projection. It's not the reality. It's a projection. And crystallization and the crystallized transparent dome plays a huge part in what I believe scientists and NASA affiliates or whatever, you know, they want to be called, astronauts, have been seeing over the decades or whatever and are not understanding. So you have what is called a constitutional repeating unit, a CRU, the smallest constitutional unit, the repetition of which constitutes a regular macromolecule, a regular oligomer molecule, a regular block, or a regular chain. A repeat unit is sometimes called a mer or mer unit. Mer originates from the Greek word meros, which means a part. And I look at that word and think more, but hey. They're saying it means a part. So the word polymer derives its meaning from this, which means many mers, which is a repeat unit. Mer is not to be confused with the term monomer, which refers to the small molecule from which a polymer is synthesized. So one of the simplest repeat units is that of the addition polymer polyvinyl chloride, whose repeat unit is CH2 squared, CHCI. In this case, the repeat unit has the same atoms, and the monomer vinyl chloride, CH squared equals CHCI. So when the polymer is formed, the C equals C double bond is the monomer is replaced by a CC single bond in the polymer repeat unit, which links by two new bonds to an adjoining repeat unit. So basically, the repeat unit contains fewer atoms than the monomer or monomers from which it is formed. So it's basically just a repeating pattern of a repeating unit. A chain, like the beads of a necklace. So NASA has a program called the ICET-2 data collection. It is basically an advanced topographic laser altimeter system known as ATLAS. The instrument aboard the Ice Cloud and Land Elevation Satellite 2, which is ICET-2. So ATLAS has a single laser split into 6 beams and arranged in 3 pairs to better gauge the slope of Earth's surface. Again, the slope, not the curve of Earth's surface. The device measures heights across Earth's surface by comparing the time it takes for a laser pulse to echo from the ground back to the receiver as it orbits the Earth. So it is exceptionally fast, shooting out 10,000 laser pulses per second, compared with only 40 pulses per second from its predecessor, the Geoscience Laser Altimeter System, GLASS. Now keep the word GLASS into your mind, because of course you all know that they have a lot of plays on words, and of course they're letting you know that there is some crystallization of course of the exterior dome, or I would like to call it the crystalline transparent dome of the Earth, hence why they named the Geoscience Laser Altimeter System GLASS. So glass transition, the glass liquid transition or glass transition is the gradual and reversible transition in amorphous materials, or in amorphous regions with semi-crystalline materials, from a hard and relatively brittle glassy state into a viscous or rubbery state as the temperature is increased. So an amorphous solid that exhibits a glass transition is called a glass. So the reverse transition achieved by supercooling a viscous liquid into the glass state is called vitrification. So familiar examples are allegedly the melting of ice or the boiling of water. The water does not instantly turn into vapor, but forms a turbulent mixture of liquid water and vapor bubbles. Now, in modern classification scheme, phase transitions are divided into 2 broad categories named similarly to the Ehrenfest classes. So the first order phase transitions are those that involve a latent heat. During such a transition, a system either absorbs or releases a fixed and typically large amount of energy per volume. During this process, the temperature of the system will stay constant as heat is added. The system is in a mixed phase regime, in which some parts of the system have completed the transition and others have not. And that alone makes me think of seasons, of course. In fluid dynamics, a vortex, vortices, or vortexes is a region in a fluid in which the flow revolves around an axis line, which may be straight or curved. Vortices form in steered fluids and may be observed in smoke rings, whirlpools in the wake of a boat, and the wind surrounding a tropical cyclone, tornado, or dust devil. And you all know that they proclaim the Southern Ocean to have whirlpool, and even the North Pole as well to have whirlpool characteristics. We all know about the convergence belts from the Southern Ocean that pretty much circumnavigates around the world, the water system. And so if you are over the Earth, you may be viewing that those vortices forming those steered fluids, and the flow revolves basically around the land bases in a circular fashion. So, allegedly, the distribution of velocity, vorticity, the curl of the flow velocity, as well as the concept of circulation are used to characterize vortices. In most vortices, the fluid flow velocity is greatest next to its axis and decreases in adverse proportion. A test to go on to, follow that path. Also, allegedly mathematically, the vorticity is defined as the curl or rotational of the velocity field of the fluid, usually denoted by a W and expressed by the vector analysis formula, where is the nabla operator and the U is the local flow velocity. Now, think here, this is the major part of this video that we're about to get into, and think mirrors. Now, mirror or looking glass is an object that reflects an image. Notice we talked about reflections earlier. Light that bounces off of a mirror will show an image of whatever is in front of it when focused through the lens of the eye or a camera. Mirrors reverse the direction of the image in an equal yet opposite angle from which the light shines upon it. So this allows the viewer to see themselves or objects behind them, or even objects that are at an angle from them but out of their field of view, such as around a corner. Natural mirrors have existed since prehistoric times, such as the surface of water. But people have been manufacturing mirrors out of a variety of materials for thousands of years. So they're letting you know here that a mirror through a looking glass is an object that reflects an image. And basically, looking in a mirror, you can be seeing something that is miles away or yards away or feet away, depending on what type of mirror that you're looking at. And I'm going to go back to the crystalline dome and crystals because I feel that there is somewhat of a similarity between the makeup of a crystal and the exterior of the transparent dome of the planet. So basically when you're looking at it, you're looking at the reverse, the direction of the image in an equal yet opposite angle from which the light shines upon it. So in fact, they're thinking, you know, that they're rotating, going around in a circle, but in fact they are not. It is a projection of, as I stated earlier, a set of reflections. And a set of reflections can be mistaken as motion.